Good morning. Today we are going to cover section 10.4, inverse trigonometric functions. So take the time to write down your title and your essential question. How do you evaluate and graph the inverses of trigonometric functions? We are going to actually take the time to graph them first, and then we'll evaluate them on example number 1. Go ahead and pause it, and we'll continue once you are ready. So if you remember how to find the inverse, we cover inverses on section 6.1. And in order to be able to find the inverse, we use the following graph. And that way we can actually just take the inverse of the function. And we're going to take the inverse of sine. So we're going to go back to 9.3 notes. And we're going to take the inverse of sine. So now your x was in radians. So now when we build a graph, or y will be in radians. So I want to make sure that I have enough space. So I'm going to have 8 squares down. 2, 4, 2, 4. And that'll be in radians. And sideways, I'm just going to go 3 and 3. So this will be 1, 2, negative 1, negative 2. And now 1, 2, 3, 4, that'll be pi. This will be pi over 2. This will be pi over 4. This will be negative pi. This will be negative pi over 2. Since we're taking the inverse, or x becomes your y, and your y becomes your x. And now I'm going to take my graph, and I want to take the inverse of this function. Now the problem that we have is that if I take the inverse of the entire function, when I take the inverse is not going to be a function. And we need our inverse to be a function. So what we're going to do instead, we are going to restrict our domain for that function to be from negative pi over 2 to pi over 2. Only from here to here. And therefore, once we take the inverse, or inverse will give us all the numbers that I need, and it'll be a function itself. So let's go ahead and graph it. I'm going to just take from negative pi over 2 to pi over 2. We're going to take that small section. So our negative pi over 2 gives me negative 1. So therefore, our negative 1 will give me negative pi over 2. 0 is 0. At pi over 2 gives me positive 1. So therefore, positive 1 will give me positive pi over 2. And the function will be something like this. That is the inverse function for sine. And we are only going to be keeping from, let me just get rid of this here. I'll place it on the left. And we are going to restrict it from negative pi over 2 to pi over 2. So we are only working with this section here. Now for cosine, we are going to go through the same process. So let's go and build our graph. I'm going to make 8 squares, 4 down and 4 down. 1, 2, 3, 4. 1, 2, 3, 4. Where this is pi, this is 0, and this is negative pi. And sideways will be just 1, 2, negative 1, negative 2. And we have the same problem. If we actually get the entire graph, we know that our inverse is not going to be a function. If I get the same from the same points from negative power 2 to pi over 2, if I get this part of the graph, when I take the inverse is not a function either of that section. And that's why we are going to restrict our graph to be from 0 all the way up to pi. We are going to get this part of the graph, and we're going to take the inverse. And that inverse is a function. So let's go and graph it. At 0 gives me 1, so therefore 1 will give me 0. At pi over 2 gives me 0, so at 0 is going to give me pi over 2. At pi gives me negative 1, so therefore at negative 1 will give me pi. So we are restricting our domain for the function, which will be now our range, to be from 0 to pi. Where for sine, we restrict it to be from negative pi to pi. So that way we end up with inverse functions. And for tangent, we are going to go back to your tangent function. And we can use more than one. Remember, tangents will repeat throughout. This is only one period. So now when we build our graph, it will be 2, 4, 2, 4. And on your x values. So this, and because on this graph, this is pi, this is negative pi, this is negative pi over 2, and this is positive pi over 2. So now if I take the inverse of one of the periods, if I take the inverse of one of the entire periods, which is here, right, continuous below, continuous above. When I take the inverse, it's also a function of a full period. So therefore, I'm only going to restrict it from negative pi over 2 to pi over 2, one full period. So now at 0 will be 0. At pi over 4 is 1, so therefore at 1 will be pi over 4, which is here. At negative 1 is negative pi over 4, so at negative pi over 4 is negative 1, so at negative 1 will be negative pi over 4. And now your asymptotes were vertical asymptotes. Now they are going to be horizontal asymptotes. The first asymptote will be at negative pi over 2. And my other asymptote will be positive pi over 2. So let me make my x-axis a bit longer, and then we can sketch our graph. So now we're taking the inverse, so the inverse will look something like this. Your y becomes your x's, and your x's become your y's. And that is a function. And we are restricting our domain to be from negative pi over 2 to positive pi over 2. So this is going to help us understand why some of the values on your calculator will be negative angles. But we also need to be able to find the inverse using a unit circle. So therefore, we're going to translate this into a unit circle. So I'm going to use 3 by 3s, 3 and 3. I'm going to do the same thing for this one. So whenever we are looking for an angle, we kind of understand what the calculator is giving us and why. And we can actually find other values if needed. So this is 0. This is pi. Our domain will be restricted from negative power 2 to positive power 2. So therefore, this is pi over 2. And negative power 2 will be over here. So our domain for sine will be restricted from negative power 2 to positive power 2. Or cosine, this is 0, this is pi. Or cosine will be restricted from 0 to pi. And our tangent will be restricted from negative power 2 to pi over 2. So this is 0, this is pi, this is pi over 2, and negative power 2 is down here. And that'll be from negative power 2 to positive power 2. And notice that it's not going to be including either value because of the asymptotes. And because before it was undefined, right? The tangent of power 2 is undefined. So let's go and highlight those sections. That means that when we get a value from the calculator, that is the value that the calculator is going to give us because we are looking for the inverse function. This is the value that is going to give us either on the first or the second quadrant. And these are the values that will be given us. So go and paste your cutout and we'll continue once you are ready. So the definition of inverse trigonometric functions. This is the function arc sine is the same as the inverse sine, which is right below. So therefore, those two expressions are the same. I can rewrite this as y equal to the sine inverse of x. The same way that we were talking about inverse functions on chapter 6, on 6.1, those two expressions are the same. Just be careful, that's not an exponent. So that's why sometimes we prefer to write down as arc sine of x. And if you're going to graph it on decimals, you want to use arc sine, where if you're going to graph it on your calculator, we're going to be using the -1 notation. So this is those two expressions are the same. If I take the sine on both sides, I end up with this notation. So therefore, our domain is going to be restricted according to a graph above for sine. Our domain will be from -1 to 1, and our range will be from negative power 2 to pi over 2. But now you understand why. The domain for cosine is from -1 to 1. Your range is from 0 to pi. And for arctangent, inverse tangent, your domain is all real numbers. And notice that for your range is from negative power 2. And there should not be an equal sign in here because it's not including due to the asymptotes. We know that the tangent of power 2 is undefined. And the tangent of negative power 2 is undefined as well. And remember that they can be written down as y equal to the cosine inverse of x. And if you take the tangent on both sides, so those two expressions are the same. The only difference is that this is written as the inverse tangent. And we're going to talk about this on the next example, example number 1. Use a calculator to evaluate each expression in degrees. So we are using a calculator. Go ahead and take the time to copy it down, and we'll continue once you are ready. So now we are using your calculator. Remember that in order to be able to evaluate this, we can rewrite it as y is equal to sine inverse, or 0.93. And we can type that into the calculator. So you want to select second. Inverse is not an exponent, it's a notation 0.93. Make sure that you have it on degrees, and I do. And that will give me y is equal to 68.4 degrees. For letter B, we can rewrite it as the inverse notation instead, called tangent. We know that they're the same, negative 0.35. And do you remember how to type that into the calculator? Because we have tangent inverse, but we do not have cotangent. So if you go back, we can go through the process. If you go back to your 9.6 notes on example number 3D, we went through the process how to be able to rewrite it from here to this notation, right? So therefore, to be able to find the, to write down, to type into your calculator, we can rewrite it as the tangent inverse of 1 over negative 0.35. The most common mistake that people make is that they write it down as 1 over tangent inverse of negative 0.35, and that is incorrect. You want to make sure that you type in your inverse tangent, then your fraction, 1 over negative 0.35. And that gives you y equals to negative 70.7 degrees. Remember, your tangent is going to be giving you from negative pi over 2 to pi over 2, from negative 90 degrees to positive 90 degrees. And the last one, how can I type cosecant? Correct. You can rewrite it as y equals to sine inverse of negative 1/3, or 1 over negative 3. So when I rewrite this, when I type into my calculator, I might use my fraction bar. If you don't have your fraction bar, you can just type in your inverse, and you just have to be careful with your 1 divided by negative 3. 9 minus by negative 3. Therefore, y is equal to negative 19.5 degrees. And that will take us to example number 2. Find the exact value. Now, when we're using a calculator, we are using an approximation, and there are certain values that we know, and that is when we are going to be using this part of the notes. Example number 2a. Go and copy it down. If you need more time, pause it, and we'll continue. Remember that this is the same as y or theta or y equal to sine inverse of negative 1/2. I can multiply both sides by sine, but most of the time we don't. We just say the sine of theta is equal to negative 1/2. So now I'm going to make it quick, 3 by 3 in a circle. And I'm looking for all the y values all the angles whose y value is negative 1/2. So let's see, sine are y values, and the y values has to be negative. So therefore, you'll be on the bottom quadrant, correct? And 1/2, is that your shorter side or your longer side? That will be your shorter side. So therefore, you can either be here or here. This angle is so therefore either will be 330 degrees or 180 plus 30 will be 210 degrees. But be careful, if you do it on your calculator, if I have it on degrees, if I do the inverse sign of negative 1 over 2, it's going to give you negative 30 degrees, because whenever we are using the calculator, it's going to give you from negative 90 to 90. So it's going to give you this on this side, but we need it as a positive, and we know that there should be another one on the left hand side that the calculator is not giving you because it's using the inverse function. Letter B. We can take the time to rewrite it as the angle of y equals, or in this case it's already written, so therefore we, let's just take the time to rewrite it. The tangent inverse of negative square root of 3. Take the tangent on both sides, so therefore the tangent of the angle is equal to negative square root of 3. I'm going to build an x and y axis. And tangent is negative. So in which quadrant is your tangent negative? Correct. It's either going to be on quadrant number 2 or quadrant number 4. And do you remember, square root of 3, is that your 30 or your 60? So it's something that you need to be able to keep in mind, and you need to be able to memorize. Tangent of 30 versus tangent of 60. I know that they both are going to be square root of 3. Which is the smaller one? 30 degrees. So that one gets divided by 3. So therefore, that will be a reference angle of 60 degrees. So that will be up here. Or down here. So therefore, that will be on either 120 degrees or 300 degrees. Now, if we do on the calculator, your calculator will only give you negative 60 degrees, correct? So if I do on the calculator, we negative my fraction bar, I need a square root. So a square root of 3, move to the right, and that's going to give me negative 60 degrees. And that is because it's getting the restriction on your calculator. It's going to give you from negative 90 to positive 90. But we know that if there's one here, there has to be the other one here. And in this case, we are going to need the positive version of it. Tangent. So I can take the time to rewrite it. Theta is equal to tangent inverse of 0. Take the tangent on both sides, so therefore the tangent of theta is equal to 0. Did you memorize those values? The tangent has to be 0. So where is tangent? That means that the y over the x has to be 0. Correct. It has to be here or here. Remember, the same thing as when you the slope of a line. Tangent is the slope of the line. So that is here will be 0. Here will be undefined. So either at 0 or at pi. Which value will your calculator give you? Your calculator is going to give you 0 only. So if I do the inverse tangent of 0, that's going to give you 0. And that is due to the restriction of the inverse function, which gives you this. Now, example number 3. On example number 3, we need to be able to find the tangent of the arc cosine of 3/4. We can actually take the time to rewrite it. Tangent of cosine of 3/4. Now, we are not looking for an angle, right? Because this is going to give us an angle, and then we're going to take the tangent of the same angle. So we actually never going to find the angle itself. We are going to use this part to be able to rewrite it. That's going to be the angle. So theta is equal to the cosine inverse of 3/4. I'm going to take the cosine on both sides, so I can rewrite it as the cosine of theta is equal to 3/4. And we're going to do something similar that we've done before, where we are going to build an x and y axis. I'm just going to do a quick 3x3. And I'm just going to make a triangle in the appropriate. So in this case, your cosine is positive, so it can be here and here. And they don't tell you where the tangent is located, so I'm just going to make it on the first quadrant. I'm going to make a quick triangle. So be your opposite over your, no, what is cosine? Cosine is your adjacent. Your adjacent over your hypotenuse, or your x over your r. So your adjacent is 3 and your hypotenuse is 4. And now I need to find the missing side. 3, 4, no, that's not 5. So therefore we have c squared is equal to a squared plus b squared. C is 4 squared, will be 16. Will be 9 plus b squared minus 9 on both sides. B squared is equal to 7, so b is equal to plus or minus the square root of 7. So it's going to be positive square root of 7. So therefore, now that we can find the tangent is the opposite over adjacent. So therefore, this is equal to square root of 7 over 3. So we know there's an angle, but we don't know what the angle is. But we were able to find the tangent of the same angle. So let's go to the next. I'm not going to take the time to rewrite this. This is the theta. This is the angle. So therefore, theta is equal to the inverse tangent of -2. Take the tangent on both sides, so I can rewrite it as the tangent of theta is equal to -2 over 1. I'll make a quick x and y axis. It's negative, and because of the restrictions, I'm going to place it on the, instead of placing it here, I'm going to place it on the 4th quadrant. Either one should be fine. They're not giving us an indication on which quadrant it is, so we're just going to use this one here. So therefore, it'll be opposite over adjacent, so it'll be -2 over 1. And now I'm going to find the missing side, because I need to be able to find the cosine of that same angle. So this is your angle. I'm going to find the missing side, so we have c squared is equal to a squared plus b squared. See what you get, and then we can compare our answers. So therefore, c squared is equal to 1 squared is 1, plus 2 squared is 4. C squared is equal to 5. C is equal to plus or minus the square root of 5. But because it's your hypotenuse, it will be always positive. So now we can find the cosine of the same angle, which is cosine is adjacent over hypotenuse. So it'll be 1 over square root of 5. And I'm going to rationalize it, will be square root of 5 over 5. And that'll be your answer. So yeah, so it's a little tricky because we actually never found the angle. But because we are looking for the cosine of the same angle, we don't need to find it once you build the triangle. Example number 4. And you should have this page with you to make the process a little faster. In this case, we're going to be using your calculator. And we are going to be using degrees. Mine is already in degrees. So the sine of an angle is equal to 0.4. I can take the time to rewrite it, but we know that in order to find the angle, we can use the sine inverse is 0.4. So that's going to give me 23.6 degrees. And for purposes, we are going to just work with whole numbers. So 23 degrees, 24 degrees, there'll be 30, 60, 24 will be a small angle here. So therefore, now remember that your calculator is going to give you only values from negative 90 to positive 90. And sine is your y value. So the y value is 0.4. But we know, and this is 24 degrees. We know that there's another y value on a unit circle that's also 0.4. So it has to be positive. So we know that the other one should be on this side, correct? That's the other angle, which will have the same y value. So what is the measurement of the angle? That is the question. Because your calculator is not going to give you that number. So how can I find it? So what is that measurement? Correct. So this is 180, and then we're going to subtract minus 24. So it'll be 180 minus 24, which will be 156. So therefore, theta is equal to either one of those two values will give you 0.4. And you can test it. We know that the sine of 156 should give you 0.4, and it does. So now, the inverse sine is negative of an angle is negative 0.25. So I'll find the inverse sine is negative 0.25, which is negative 14.4. So we got negative 14 degrees. So negative 14 degrees is down here, small angle. And first I need the positive version of that same angle, because I want it from 0 to 360. But your calculator is going to give you from negative 90 to 90 degrees. So therefore, what should I do to be able to find the positive version of the same angle, the coterminal angle? I need to add 360 degrees, and that's going to give you 346 degrees. But we know there exists one more angle whose sine of the same angle is going to be negative 0.25. So it's a y value for sine is the y value. So therefore, I know that there's another angle on this side whose y value is exactly the same. So what is that angle? So how can I find the measurement of that angle? Correct. So I'm going to go 180, and then I'm going to go this bit more, which is 14 degrees. So it'll be 180 plus 14 degrees, which is 196. So now try the next one, see what you get. So did you get it? So therefore that is 0.81. That is 54 degrees. And I just needed 45, 54 should be a little higher. So right here. We'll make my triangle, and that is 54 degrees. I know there exists another angle whose y value is exactly the same. And yes, that will be over here. Let me make my triangle. And the y value will be exactly the same. But what is the measurement? Correct. It's going to be 180 minus 54, which will be 126. And I can test it by saying the sine of 126 degrees should be 0.81. And it is. Now let's work with radians. So I'm not going to change my calculator back to radians. So now it's in radians. So the inverse of the sine is 0.9. The inverse sine of 0.9 will be equal to 1.1 radians. So where's 1.1 radians? Remember, the radians, if you take your radius and you wrap it around, it's about 57 degrees is 1 radian, so just a little higher, right close to 60 degrees. So the y value is 0.9 here. Maybe higher. So there's another angle. This is 1.1. Another this is 0. Another this is pi now instead of 180 since we're working with radians. And my screen froze again, so I'm afraid that if you can be patient enough. So there's 1.1 radians. We know that 1 radian is about 57 degrees. So there's another y value that has the same sign, or there's another angle that has the same y value, which is over here. So how can I find that angle? Correct, same thing that we did above. It's going to be pi minus 1.1. I'll select pi, 180 minus 1.1, and that will give me 2.04. And that was pi minus 1.1. How about for the next one? The inverse sine of negative 0.62 in radians will give me negative 0.6. So I'm going to have to use one decimal place. So negative 0.7. 51 radians are around here, so probably a little less. And we're looking for the sine, which is your y value. So there's another angle. Well, first I need to find the positive version of this. So what do I need to do in order to find the positive version? Instead of adding 360, I need to add 2 pi. Right? Because 2 pi is going all the way around, landing on the same location. So those two are going to be coterminal angles. So 2 pi minus or plus my answer. Or let me just do as a decimal. Minus 0.7. Let's just do that. That'll be 5.6. In 5.6, we know that it should be, this is where the angle that we're looking for has the same y value. What's this one? 5.6 is here. 5.6 and negative 0.7 are coterminal angle. So we're looking for the other angle. How can I find the angle? Correct. We're going to go pi plus 0.7. That will give us 3.8. And let's do 3.84. And if we take the sine of the angle, the sine of 3.84, that should give me negative 0.62. Close enough, since we're running off so much. So try the next one. See, use your calculator to be able to find both angles, and the angle should be between 0 and 2 pi. So that's what we don't want as a negative. You got it? Go and pause it if you need more time. So therefore, I'm going to take the inverse sign of negative 0.37, and that will give me negative 0.37, negative 0.4, negative 3 points. Let me just leave us 2 decimal places. So 1 radian is here, so half a radian, so it should be a small angle. So this is negative 0.38. Let's do 2 decimal places. I need the positive version of it, so therefore I'm going to add 2 pi all the way around to be able to find the coterminal angle. So I'm going to add plus 2 pi. That gives me 5.9. Perfect. Now there's another angle that has the same length for the y value, and that will be on this location. So how can I find the angle? Correct. You go pi plus a bit more, which is a 0.38. So therefore, it'll be pi plus 0.38, and that gives me 3.52. Right? Pi is 3.14 plus a 0.38. And those are the 2 angles. And I can check by doing the sine of 3.52. Should give me close to negative 0.37, and it does. How about for cosine? How does that work? First, let's go and do it in degrees. So let's go and change your calculator to degrees. And I'm going to take the inverse cosine is 0.4. And that is 66 degrees. So therefore 66 degrees is 30/60. It's up here. And now cosine, and that's 66 degrees. Cosine is your x value. Now your calculus only giving you one value. Your calculus giving you values from 0 to pi, from 0 to 180 for cosine. But I know that there's another one that the calculus is not going to give me. Where's the other angle whose x value is exactly the same? Correct. It will be down here. So what is the measurement of the angle? How can I find it? Correct. I want to take 360, and then I'm going to go back the same amount, which is 66. I'm going to take 360 minus 66 will be 294. So therefore, this is 294 degrees. The cosine of an angle is negative 0.25. So I need to be able to find it. First, I want to use my calculator to find the inverse cosine of negative 0.25, which is 104 degrees. So therefore, 190, 104 will be somewhere up here. And the cosine is your x value. So therefore, there's another angle that has the same x value. Where is it located? It's located down here. But what is the measurement of the angle? How can I find it? To be able to find it, I'm going to go 360 minus this angle, which is 104. $256. And yeah, that angle looks like a 256 degrees. Once again, if I want to confirm it, I can do, and that is an approximation just because of our rounding. So try the next one. See what you get. Let's see. The inverse cosine of 0.81 is 36 degrees. So 36 degrees is here. So where's the other angle who has the same x value? That'll be down here. So this is 36 degrees. How can I find this angle here? I'll do 360 minus 36 degrees. That gives me 324. So now see if you can do it with radians. So change your calculator to radians, and let's go through the same process. So now that's in radians. So cosine inverse is 0.9. That's 0.45. Let's use 2 decimal places for radians. So 0.45. Remember, 1 radian is here, so halfway, just a little more. So probably is around here. So it's positive, not negative. So positive is 1 radian, so it should be around. Not this one here. So now we're looking for the other angle. So this is 0.45, who has the same x value, since this we're working with cosine. And yeah, that one should be down here. But I need to erase it after all. So therefore, how can I find that? This is pi, this is 2 pi. So I want to go all the way around, and then I want to subtract it, which is 2 pi minus 0.45. So therefore, I'm going to type in 2 pi minus 0.45, and that gives me 5.83. So the nice thing that whenever you're working with cosine and sine, with cosine, that it's only going to give you from 0 to pi. It's not going to give you anything negative. So therefore, we don't have to do any of this. We're never going to get a negative value, so we don't need to add or subtract or add 360 to find a coterminal angle. So the next one is the inverse cosine of negative 0.62. That gives me 2.23. Remember, this is 1 over 57. 2 will be 114. That's a bit more. Close to 120 probably. Maybe a bit more. So therefore, this is 2.24. Where's the other angle who has the same x value? That'll be down here. And how can I find what the angle is? Right, I'm going to go 360 minus 2.24, or 2 pi minus 2.24 will give you 4.04. So I did 2 pi, and then I subtracted the angle. So try the next one, see what you get. I want to do the inverse cosine of negative 0.37, which is 1.9. So it'll be 157, 2 will be about 114, so 114 degrees. So where's the other angle? It has the same x value, so that'll be down here. So therefore, I'm going to go through the same process. I'm going to take 2 pi minus 1.95, which is 4.33. And last, we get to tangents. And we left tangents to the very end just because tangents is much, much easier. And we're just going to do it in degrees. So I'll take the tangent, inverse tangent of 1.2. And that gives me, and I need in degrees, not in radians. So let me go back and change my calculator to degrees. That's in degrees. And I can enter it. 50 degrees. So 45, 50 is located here. So this is 50 degrees. Now, because your tangent is your y over your x, your tangent will always be 180 degrees over to the other side. Will be the same because this y will be the same as this y, and the x will be the same as this x. And now this is a positive and a positive. This is going to be a negative and a negative, which will give you a positive value. So therefore, you just need to be able to add 50 plus 180, which is 230 degrees. So that's what's nice about tangent. On tangent, you don't have to think about it. You just do 1 plus 180, and you get to this correct angle. So let's try the next one. In degrees, inverse tangent is negative 2.4. And we end up with negative 67 degrees. So negative 67 degrees, negative 30, negative 67 is around here. Now, remember the tangent is going to give you from your calculator from negative 90 to positive 90 degrees. I need the positive version of it. So therefore, I need to add 360 degrees to find the coterminal angle. So I'll do 360 minus 67 will give you 293. So this angle is 293 degrees. Therefore, my other angle will be 180 degrees. So I just make a straight line over to this side or that side. That's my dog growling. That means that my notes are taking too long. So therefore, I can do negative 67 plus 180, or I can do 293 minus 180, which 293 minus 180, and you end up with 113 degrees. And now for the last one, see what you get for the last one. Negative tangent of negative 0.47 is negative 25 degrees, which will be 36, so a little smaller than 30 degrees. I need the positive version, so I need to add 360 to find the coterminal angle, which is 334 degrees, 335 if we do 360 minus 25. And now to find the other angle that has the same tangent will be just 180 degrees over. I'll do negative 25 plus 180 degrees, or I can do 335 minus 180 degrees, whichever you prefer. That gives you 155. And I can confirm that the tangent of 155 should give me negative 0.47, and it does. So this will conclude the lessons for today. Have a great day, and I'll see you next time.